Hi everybody. Hello and welcome to the York Universe, the Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I'm Mary Helen Armour, one of your hosts this evening, and joined by Dr. Elena Hyde. We are broadcasting live from the Allan Carswell Observatory, located on the Keele campus of York University, Toronto, Ontario. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time at York U Observatory. Okay? We also run in concert with our online public viewing, or as we call it, the OPV feed, done by the York U Observatory staff. Okay? To navigate to our live show or find out more about us, please check out our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. You can ask any questions or comments. You can ask about past shows. You can put suggestions for future topics. And please send us any sort of ideas like this at observe@yorku.ca. You can also connect with us on Instagram with the handle @York Observatory or on Facebook at Allan I Cars Web Obs. Okay? All of our programs are free, but if you would like to make a donation, we would certainly appreciate that. If you see the yorku.ca/science/observatory website, there is a option to make donations. And for tonight's podcast and OPV, we will have a live YouTube chat for questions and for posted content. Tonight's weather isn't looking too bad for observing, and we will have staff in the dome, so hopefully we will have some live images a little later in the show. It's getting to that time of the year when the sun only sets very late, so the first few images will be sort of from our past observations. We'll have a mix of the live and archival images. Okay. So let's get on with our show this evening with some astronomy history. So welcome as well, Elena. Um,
Yes, thanks. It's great to be back always on the radio show. I'm just hoping that haze doesn't interfere too much with the possibility for live views. And I guess just as a reminder for anyone listening to the podcast, if you want to catch the live views, you'll have to go over to that YouTube channel.
Yeah,
Um,
so and I apologize if I was a little MIA for the first minute or two. My clock doesn't seem to be synced to quite the same time as my computer. So my apologies for a little bit of confusion there on the start. Um, so we can dive into though this week in history. So as always with the podcast, we do a little bit of space astronomy history. I tend to be a bit more of an ancient history buff. So I'm looking back uh, first only a few years around this week in 2008 and then again in 2012 we had transits of Venus across the sun. Now these only happen about every century or so. The next one won't happen until 2017 now, but to an observer it's something very cool to see because you see the dark dot transiting across the sun, that is Venus. But I think sometimes, like when we do modern observing, we forget a little bit of the historical context and how some of these observations can really have had a lot of implications. And the transits of Venus were quite important because if you think about it, how do you measure how big the solar system is? How do you measure how far the Earth is to the sun? And it was in the 1600s and into the 1700s that they were starting to think about how to do it. And it was Edmund Halley, the same guy who sort of predicted the return of Halley's comet, who first suggested using transits of Venus in particular to figure out the Earth-Sun distance. Now, there's sort of a bunch of trigonometry and everything involved, and it's very easy to find some of these searches on the web. Um, but what they did then is they made some very detailed observations of the next transit of Venus after sort of Halley had suggested this. These were in 1761 and 1769. And astronomers literally sailed to locations all over the globe to catch this. And then over the next couple of years, um, they actually managed to calculate the Earth-Sun distance, and they did it in about 2% accuracy, which by the standards of the time was very, very good. So if you think about it, although we talk about like planets and orbits and all this kind of stuff, and you had Kepler and Newton and all these guys working on orbits, we didn't actually know how big these orbits were until they used these Venus transits. Now, the one in 2004 and 2012, we already knew the Earth-Sun distance. We've got lots of other ways of figuring it out now. But some astronomers did try to sort of replicate the measurements and the calculations to see how accurately they could get it. But again, these transits are fairly rare. They only happen about every century or so. The next one won't happen until 2017, and then about 8 years later. So you always get them in pairs. So you'll have just over a century that passes, and then you'll get one, and then about 8 years, roughly 8 years later, you'll get a second one, and then you don't get another for just over a century. Wikipedia actually, if you look under Transit of Venus, has a really nice table that shows sort of a bunch of these past ones and then a bunch of these future ones. But like these are fascinating observations. But when you go back, before you had really significant telescopes, before you had radio astronomy, before you had so many of the techniques that we use now to measure distance, they had to be very, very clever to sort of figure out what the size of the solar system was. And I guess I'm always fascinated a bit about some of this more historical observation approach. So, the last transit of Venus was, 2004, 2012, so a few years back now, but it'll be almost a century until the next one at this point. And there's kind of a funny twist to this because Edmund Halley suggested using the transit Venus, which occurred long after his death. But when he predicted the return of Halley's comet, he also predicted it to happen long after his death. And he took a bit of flack for that, for the Halley's comet in particular. It's like, well, it's very nice to predict something after you're likely to be dead because you're like, who's around to, you know, um, call you out if you were wrong because it's too late at that point. So it's kind of interesting that so many of these things that Halley predicted were for times long after he would have, been out of the picture. So,
Yeah, it's always a bit a little bit interesting when it's like, well, you're not going to be here to see it. But, he did a pretty good job.
he did a very good job. He was very clever in how he took a lot of Isaac Newton's work and actually applied it to a number of situations. And Halley was an interesting character because he was also one of the first people to come up with mortality tables, which are things now used by insurance companies to look at sort of population um, patterns. So he was also doing that. So it was he was a mathematician, but he applied it in many different fields. So he was quite an interesting character all around.
Oh yeah, and I mean the transit of Venus was such a hot topic in the 16 and 1700s um, for this exact reason. And of course, as you mentioned, just the idea that you could make this calculation was very, very spicy and really, really interesting to a lot of people. I think it was in the 1600s. Kepler predicted the 1631 transit, or no, he predicted the 1631 transit, or 1627. I can't remember which
Yeah,
year
it's
he
it's it's
actually
in
did it.
that time period. Yeah.
Yeah, yeah, and I believe he did get a mean estimate for the distance between the Earth and the Sun, and um, you know, uh, got some all kinds of interesting calculations out of it as well. And there was a whole bunch of people sort of competing to get to the next, transit of Venus, to see, if they could do the next best calculation. So it
Yeah.
was sort of this really hot time in the 16, 1700s for, I don't know, a hot time for hot planet.
Oh, and it's interesting. We're kind of we have like the dry historical facts, but you kind of forget it was very much a bit like the space race of the time, where all these guys were going out, and we don't think of anything of traveling around the globe now, but this was by sailing ship, and in the 1600s and 1700s, you're still right at the beginning of accurate navigation, and it was still a very risky thing. This is also about the time I think Captain Cook was doing some of his voyages around the world, and he was involved in this as well. I mean, we think of him as, discovering Hawaii and Australia and stuff, but he was involved in this as well because this is how big it was. Even people who weren't really astronomers were involved in the process, and they were traveling like worldwide in very much where travel was much more dangerous and much more involved than it would be today, the way people like to fly around the world to observe eclipses. They were trying to do.
Yeah, yeah, and it's interesting how much of it is based on, what came before in so many ways as well, because of course a lot of those sort of translated manuscripts that came over, with the sort of the Renaissance basically, and I do wonder how many of the old manuscripts from people like Al-Biruni, who was doing the calculations of eclipses and the size of the solar system like 600 years before that, and was it 1020, 1030?
Yeah.
Um, and it's just, all of these things are so interesting and so interrelated. And of course, as you say, the a lot of the folks in Europe, they had not mastered the navigation of the Polynesians, so finding their way out to some of these
It's-
places was a little bit harder.
yeah, I mean,
But
the risks were on par with the way space travel is today, right? I mean, it was the space
yeah,
travel
I mean,
of
the
its
main
day
thing
to
is
do
it's
this
like,
kind of thing.
yeah, if your ship broke down, you potentially could build another one and bring it back, but it was incredibly dangerous, and a lot of people didn't succeed. I believe there was one fellow who famously, gosh, what was it, like a 25, 40-year voyage, and he missed his chance to get the transit. Um, but yeah, there's some amazing cases of just um, incredible tries that worked and also ones that didn't.
You don't hear about the ones that didn't so much, but they sometimes make for some very interesting stories.
Yes, yes, I'll have to look up that one guy who got lost. But there've been some very unlucky people as well as a few lucky ones who were in the right place at the right time. And of course, Kepler, as I say, coming before and having an extraordinarily interesting time of things happening in astronomy was quite nice as well. Um, but
So,
yeah, there's a lot going on out there, and of course, transits of Venus and Halley's comet are pretty much kind of like almost opposites, because on the one hand you've got the incredibly hot, close to the sun planet Venus, and on the other hand you've got this little tiny cold icy comet coming in. And actually, it was one of the translations of that comet was actually in the Chinese records that came through. Was it the Silk Road trade route?
was like I say,
Um,
Halley's Comet, if you look back, had been recorded for hundreds of years
yeah,
before Halley made his calculations, and it was through a whole lot of them. Some of them from Europe, it's like you said, some of them from Asia, and a lot of this got pulled together for him to create, this potential orbit for Halley's Comet when he found that.
yeah. Well, the oldest records we know of that have ever been published were definitely the Chinese astronomers.
Oh yeah.
Um, and it's just they had probably, or arguably, I suppose, the best maps at the time. We don't really know if someone else had maps that were on less preserved items, we wouldn't know about it. But yeah, it's these things. One of the great things we talk about, in the modern area is being able to easily share information as well. So it doesn't take decades for it to get from Asia to, I don't know, Canada, for example.
Yeah. Or longer. I mean, these records are made and then they just kind of sit until someone rediscovers them and sends them on. So yeah, it's such a different world we live in with the discoveries we make now as opposed to what happened even, even going back to the 1800s. Information just traveled so much more slowly, right? And everything had
Yeah,
to be
and
done by hand.
it's
There were no computers.
I'll just give a little shout out to the Internet Archive where a lot of the originals have been scanned and uploaded.
Yeah.
So if you are looking for some of the original publications from especially people like Kepler and Halley and some of the others, those are all out of copyright and they're all up on the Internet Archive.
Oh yeah.
So,
Well, I think it's the Gutenberg project too has a lot of those works
yes,
as well.
and
They're another
yeah,
good
between
one.
Gutenberg and Internet Archive, you can find some amazing stuff for sure. And actually, I think they might have cross-listed them, but I'm not totally sure on that.
Yeah.
Um, so, anyways, I should probably talk about some small cold objects.
From hot Venus to cold to small and cold.
Yes, so I'll do the more technical, I suppose, recent type discovery genre, and get us to something that is not at all hot, and not particularly close to the sun. So back in 2019, on May 30th, an amazing picture was taken. This picture was taken of an extreme close-up of the asteroid Ryugu. And this was a real showstopper. It was absolutely, never seen before sort of moment. Um, and this was when Japan's Hayabusa 2 spacecraft um, got close enough to get this incredible, only 30 feet away, which is really, really close, picture above an asteroid. They actually had another photo opportunity, and they dropped what's called a target marker on the asteroid. And while they were going over, it took this amazing, super duper duper close up picture. And they were actually going and trying to collect debris. So I'll tell you a little bit more about that because it's got two really interesting components. One is the Hayabusa 2 craft, and the other is the actual asteroid Ryugu, or if you want its full name, it's 162173 Ryugu, because we always have to have a specifier, I guess. Um, so Hayabusa 2 is a Japanese space agency mission. So that's JAXA, and it's a successor to, of course, there was a Hayabusa 1. So just like movies, when you have a sequel, they've gone with the movie sequel naming convention. And the Hayabusa was a little robot spacecraft that was going to return a sample from a near Earth asteroid. And so the Hayabusa studied the asteroid's spin and shape and color back in 2005, and it collected samples which actually were returned to Earth, which is pretty darn amazing. And that was back in 2010. So Hayabusa 2 was a follow-up, sort of a sequel to the grand smash hit that was Hayabusa. And it went to the asteroid Ryugu on the 27th of June 2018. And the official rendezvous was the 27th of June. So you might be thinking, aha, that's not the same date. So the close-up photo actually was May 30th. So it took another 27 odd days for it to actually officially be in rendezvous with the asteroid. But this super duper close up picture happened on the 30th, which is this week in space and astronomy history. So I got around it that way. It was a pretty successful mission as well. It surveyed the Ryugu. Well, so I'll leave off the numbers in my future future descriptions. and it returned samples to Earth. And so it did come back, and it also returned samples of an actual asteroid back to Earth, which is amazing. So that happened in 2020, which is now we're talking very recent history. Like it was basically yesterday. So it was, 5 years ago, but still it seems like yesterday. So it has been extended and it's still there. Hayabusa 2 is still there out in space. It's actually been extended until 2031, and they're sending it off to another asteroid, 1998 KY26, which doesn't have that cool of a name. So Hayabusa 2, officially arrived a few days after its super close, awesome 30 feet away picture. And it remained about 20 kilometers to map the asteroid. And it went into sort of a low hovering altitude. It actually ejected rovers onto the surface, which is also really, really cool. So the Hayabusa spacecraft ejected two rovers. Rover 1 was called Haibo, and Rover 1A was called Haibo, and Rover 1B was called Owl. So they weren't 1 and 2, but I guess we lost the movie naming convention. So it ejected them and dropped them onto the asteroid. And you might think, okay, well, they're dropping these rovers on. Are they going to just crash and create a crater? Well, no, because they weren't going that fast. They had matched up with the asteroid, and the asteroid really does not have very much gravity. So it's not like Earth where you drop something and it just slams to the ground and you get, a sore knee. This is sort of
Or
you fall
smashed up
very
samples if you
slow.
don't catch the parachute.
Yes, exactly. So this very slow dropping of things, much slower than even you see in the old lunar footage when the astronauts were falling down, which is really fun, by the way. Everyone should go watch astronauts fall down on the moon. Um, but this is a grand success. Dropped these amazing little rovers onto the asteroid, and they lasted for about 16 hours, which was what was planned. They didn't last much longer than that, but they did a ton of work on the surface. They not only did they map it, they had the rovers drive around, they did all kinds of tests, they had samples taken, and one of the things they did was, of course, give us a huge amount of new information about Ryugu. And so I did say Hayabusa 2 is still going. It's still going to another asteroid, and it's got lots of cool thermal infrared cameras and spectrographs and stuff like that to investigate things. But for the next part of this, I'm just going to tell you a little bit about Ryugu because this is actually not just any asteroid, it's a near Earth object. It's a potentially hazardous asteroid. Nothing to worry about, don't panic, but potentially something to maybe keep an eye on. And it's what's called the Apollo group, which is a group of asteroids named after the asteroid 1862 Apollo, which was discovered, and this you'll like this, Mary, back in history in the 1930s. So this is any kind of Earth-crossing asteroid, so it goes past Earth's orbit that has a semi-major axis greater than Earth, but a perihelion less than Earth. So they sort of have this interesting orbit where they sort of wibble wobble in and out of where Earth is orbiting. So if it's coming across our little roadway here, so if you can imagine the Earth on a little tiny road driving around the sun, we have these. These are basically the deer you have to watch out for, or the elks, I guess, depending on where you live, or the kangaroos, actually. So yes, you got to watch out that they're not going to collide with you. They're not huge, right? So one of the things we wanted to know about this asteroid was, how dangerous is it? Is it really solid? Is it really massive? What's it made out of? What kind of shape does it have? What would this do if it would hit it? if it would hit Earth. And this is an interesting one. It seems to be part of a type of asteroid that is not super dense. It has sort of a strange shape, almost like a spinning top. And there's another asteroid that looks like this too. It's called Bennu, which has also been in the news. So really, really interesting asteroids for two here. Um, so Ryugu is quite young, we think. It's based on Hayabusa's 2 observations. We think it's only 8.9-ish million years old. There's an artificial crater that was created with an explosive by Hayabusa 2, which is, again, really, really awesome. And it's got this surface that is really odd. It's very porous. It contains little to no dust, and it seems to have just different types of black rock and um, no really internal cohesion, so loose black rock, but no dust particles. So it's some sort of dark type of rock with sort of interesting features, and of course they brought some of it back to sample analyze. And it does have large boulders on its surface. It has copper, and it has, different types of material on the inside and outside. So they did actually find out that it has a fairly complicated geological history, it looks like. And when they brought the samples back, they had several phases of analysis from the Hayabusa 2 samples. They found that they were actually formed at very high temperatures. So the grains and the rocks in the asteroid were formed at temperatures like those close to the sun, 1,000 degrees Celsius, and then probably transported towards the outer solar system. So something somewhere got really, really hot, and eventually it formed this thing. And of course, we always have to talk a little bit about size. So if you're familiar with how big a meter is, this thing's entire dimensions is only about 1,000 meters, or that's 1 kilometer. So that's not a huge thing. I mean, it's bigger than your car, probably bigger than my house, but
Big enough to
um,
make a good sized hole in the ground if it hits you.
yeah, it's not the size of a city or the size of the asteroid that killed the dinosaurs. So it's a really interesting asteroid, and it's a really interesting mission happening all the way back in 2019. But I do have to say, it is also a news item this week, um, or well, a couple weeks ago. So I'm cheating a little bit, because some of the deposits on that asteroid have been found to have salt minerals in a recent paper from Kyoto University. And um, salty water is something that we're really interested here on Earth because, of course, that's what is in our oceans. So, how did salt minerals get onto Ryugu and become part of its chemical history? So that's actually, gosh, let me see. Oh, I lied a little bit. It was published in February. Really, really fun article. So we can talk about that more if we run out of other things to talk about later. But it's all the way from 2019 to late breaking news right now, and it's still going.
So back to just a quick nod to astronomical history, because as most people know, we are coming up on the solstice. It makes evening observing challenging since we have to wait until it gets to be full dark. But of course, we are coming up to the solstice and going back to this kind of ancient measurement thing. Uh, it was using sort of the solstice that we actually first measured the size of Earth. We talked about the size of the solar system. Now we're going back even farther to a fellow by the name of Eratosthenes in the third century BCE. So you're now talking, 2,300 years ago. And he used sort of angles of shadows cast at the solstice, where there was one location where no shadow was cast on the solstice, And where he was in Alexandria, there was a shadow, and he used the basic geometry to work out the size of the Earth. Now, it's like I said, we don't know exactly the number he got because the unit of distance he used, we're not entirely sure how long it is. But he was accurate to within a few percentage. He did get a value somewhere just over 40,000 kilometers, which is pretty close to the modern number. So, we think of sort of, ancients as maybe like less technically capable, but within sort of the technology that they had, they did a lot of really interesting measurements and a lot of really interesting work. And so this is sort of one that always comes up when you talk about uh, sort of technological advances or, advances in understanding. When we figured out the size of the Earth, well over 2,000 years ago and knew even, a few hundred years before that that it was round thanks to guys like Pythagoras and that group. So, but I think you were going to take us back to some more modern stuff.
Oh yeah, and of course, if as we go back and forth, it is worth noting that these things are all related, and I think it was also Al Biruni, as we say from quite a bit earlier, was a year 1000 AD or so,
Yeah.
who had the estimate of the estimate of the size of the Earth large enough to justify another continent being out there somewhere over the ocean. Um, so even then, they had, sizes of the Earth very, very large. And I think one of his methods was, and I'm trying to remember, using the shadows from mountains,
Yeah.
which was really, really cool. And there's just, of course, now we know that there's some subtleties to some of these calculations, and we have, of course, computers to help us. But the fact that they're able to do this so accurately and make, in the end, really, really accurate yearly calendars for all kinds of purposes, including, agriculture and development and all that stuff, is, I think, would be a challenge for any of us now to reproduce, especially if we didn't have our technology helping us.
Oh yeah, the time that was invested into see some of these calculations and stuff is, if you think about it, it's just phenomenal, right?
Absolutely. And speaking of things that take a lot of time, I'll, I'll get to my next item that way. I'm going to go back to, after all of these thousands of years of development, we finally get to the point where we can actually get to the moon. And in 1966, there was a lot of interest in the moon. In 1966, there was all kinds of lunar activity happening because, of course, we had the space race, we had NASA, we had Russia, we had the Soviet Union. We had all kinds of interest in the moon, in space travel. People were planning their lunar colony getaways. And on June 2nd in 1966, a lovely little craft called Surveyor 1 actually made its landing. And it did take about 63 hours of travel time, which is not months and months, but it's a fair amount. So it's 63 hours after its launch, it landed on the moon. And this craft was 2,200 pounds, or about 998 kilograms. And they were trying to aim it at the moon and not have it crash into a crater. So I will just say really quickly that if you are watching the live stream, or if you do want to go back and watch the live views from online public viewing, they are actually showing some lovely craters on the moon. Not necessarily these ones, though, because this craft was trying to land north of what's called Flamsteed crater in the Oceanus Procellarum, or what's also called, in a much easier way to pronounce, the Ocean of Storms. Not a real ocean, but it's what we've been calling oceans on the moon, or Mara, the lava fields.
Yeah.
So Surveyor 1 took photographs and sent them back. It took about 11,000 photographs, which is, I mean, not a lot now, but it was a lot then. And they measured the moon's temperature and just, to see like if you landed on the surface, would you just like sink in? Could the surface hold weight? We didn't know. But it could hold 2,200 pounds, so that was pretty safe. And it was up there to pave the way for the upcoming Apollo missions. And I'll just note that they had at the time a 62-mile or 100 kilometer wide circle that they had to aim for with this craft because going to the moon is really, really difficult, and landing in a specific place on the moon is incredibly challenging. So they have what are called sort of target areas where they're like, well, we just want to put it down somewhere in here. And the target areas are still fairly large, not as large as they used to be. But back in 1966, they were aiming for a 100-kilometer wide region. And that is, of course, partly due to the technology and partly due to the fact that they didn't have the very best of maps at that point. So Surveyor 1 actually transmitted not just images, but video data from the moon after its landing. Um, and they did actually air the video data on some television networks. So if you have the live video, it might be out there actually on the Internet Archive somewhere. I haven't managed to find it recently, but the video was aired on some live TV networks in 1966. It's kind of cool, the idea that you could have seen this all the way back then, real live TV feed from the moon. And of course, the TV feed was very different than what we have now with our digital televisions. This was a old-fashioned, what was called Vidicon tube, which was based on a cathode ray tube, which are very old television technology. And then it had a zoom lens on the end of it to give you optical fields of view. And then it had shutters with orange, green, and blue optical filters. So it could take pictures with different sort of optical band passes and then they could be combined. So it's pretty interesting technology. And of course, each 600 line picture has to be read from the VidCon tube and it would go over radio broadcast or TV broadcast. So the data transmissions had to be converted for closed circuit and broadcast TV. And every line in the 600 line picture, so each picture has 600 lines, it required 1 second to be read from the Vidicon tube. And it broadcast, I believe it was 220 kilohertz. And so it was reading this image line by line, and your image would only have 600 lines. So we're not talking super high resolution. So 600 seconds later, you get one image. But there are some lovely images that have come down there. You've got Surveyor 1's shadow against the lunar surface. And then you've got pictures of the Mara and the irregular craters at the landing site and some interesting rocks they found, some modeled rocks, which I think helped them identify some of the volcanic activity. And interestingly, this Surveyor 1, it wasn't just in 1966, it was actually reactivated January 6th, 1967 for 12 hours and returned data on the motion of the moon, which actually was used to help change and refine the map of the moon's orbital path around Earth, as well as get a better distance between the two, because when they first sent this out, we did not have the accuracy that we have now. So ideally, this would have mapped out the distance, the orbit, a lot of the properties, so that you could, in theory, maybe even send humans, which of course they did go on to do.
Oh, I mean, yeah, it's like you said, some of this historical stuff, it's fascinating because you'd still get some of these original videos and images. So just a reminder, you are listening to York Universe. We are broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. Please look at our website, yorku.ca/science/observatory to join the chat. If you have any questions you want to see, or you're looking, um, it'll take you to the YouTube link where you can see the live images that are on OPV. Tonight you are listening to Dr. Elena Hyde and myself, Mary Helen Armour. We've been discussing sort of a number of historical items. And again, you can navigate to the web page to see the online public viewing. A couple of other reminders of some things that are happening at the observatory. As is the case most weeks, we will be hosting live tours this Wednesday at the atrium. Tickets are free, and a link can again be found on the website to get them. Tickets are free, but donations are always welcome because this is entirely sort of run sort of on donations from the public. On alternate weeks, we do mix up viewing events on the fifth floor of the Arboretum garage. And these events, weather permitting, we look at some of the celestial objects through a number of sort of smaller telescopes that we have available for public viewing. We tend to do this in the summer and spring months when it's sort of warm enough and weather permitting to be up in the garage. We also have coming up our York Allan I Carswell Observatory Open Air Astro Fair, which will happen on the first clear night between June 24th and July 4th this summer. We'll make an announcement every day at 9 a.m. as to whether this is the day because the weather looks really good or not. The event will run from 5 p.m. to 11 p.m. They'll be observing, planetarium show, booths to buy great swag, and lots of other activities with various partner organizations. You can find the details and the events again at our website, www.yorku.ca/observatory/science/observatory/astrofair. It's set up to be a great family event, uh, and it's sort of towards the end of the school year. So if you're bringing your family, getting up early to go to school the next day isn't really an issue if you end up staying later to be there past sunset to have some of the observing.
Oh,
Uh,
absolutely. It's going to be really fun.
So now we're moving on to a little bit of some bits of sort of current news. And I don't think you can have current news in astronomy right now without talking about the James Webb Space Telescope. And one that sort of popped up across one of my feeds today was looking at a very, very early galaxy. Now, the things we have to remember when you look so far away, you're really looking back in time. Because, of course, even light takes time to travel. So a light year is how far, again, light can travel in a year. So if something's 100 light years away, the light you're seeing actually left that star 100 years ago. This galaxy is billions of light years away, and we think we are looking at the galaxy um, something like 280 million years after the Big Bang. So this is very, very early on in the history of the universe. We think this might be one of the very first like one of the very early galaxies to form. Because you have to remember the universe now is almost 14 billion years old. So this is sort of very, very early on in the history. And JWST is just a great news topic because they always seem to have something popping up, and it's such a broad variety, whether it's galaxies. This particular one is M0MZ14, and it's like I said, they think it's about it formed only this. You're looking at a galaxy that was forming only 280 million years after the Big Bang. But JWST, it looks at some of the far away, it looks at galaxies. Another article I saw pop up just recently was about finding frozen water in young solar systems. It looks at exoplanets, uh, and it even looks at objects in our solar system. It's been observing some of the weather on Titan, for example. So this is always a great one if you like to sort of follow new developments. Um, Another really cool one, and sort of touching on sort of the theory, sort of the earlier themes of lunar exploration and sort of the Japanese space exploration. There's a company called iSpace that is looking to make a historic moon landing June 5th um, at about at 7:24 GMT. They're actually going to live broadcast this on YouTube. So they have a YouTube channel. They're called iSpace. And you can sort of, they will start streaming about an hour before the landing is supposed to happen. So this is another sort of great, it's news, but it's also what's happening sort of right now and what's happening this week. And that might be a really interesting live stream to watch. I don't know if maybe the observing crew can grab the address of that live stream and drop it into the YouTube chat if people are interested in looking at something like that. I mean, lunar topics and lunar landings are always fascinating to me.
Oh yeah, and I think if you just search for it, it'll show up in pretty much any search browser that
Oh
you
yeah.
want, your DuckDuckGo or whatever. Just to search for but it actually is interesting because it's landing in a very different area from what we were talking about earlier. It's going for the Sea of Cold. Um, and this is Mare Frigoris, which is in the moon's northern hemisphere. Which should be, if it works, it will be a massive success. But I do have to say, a lot of companies have failed recently in their launch attempts.
Well,
So
this is
I
this
hope
is
they do
the
better.
this is their second attempt. I think they did get the other one to touch down, but failed to send anything back. A year or two ago. So this is their second attempt
Yeah.
at landing. So hopefully they'll be a little more successful this time around. But even in their failures, you learn things, and then the next time, hopefully, it works better.
Oh, absolutely. And I did just actually find the channel. So if anyone is interested, it's literally just iSpace on YouTube.
Yeah.
So ISPACE. There you go.
Yeah, it's easy. It's easy to find on a search. But that's the moon. I think you had a couple of others that you
Yeah,
wanted
there's
to
a
get into.
lot. There's always so much space news happening. So one of the things I couldn't resist putting in there was the aurora, which I know we're going to talk about because it is also in the news tonight. So we have had a fairly active sun. That solar maximum is still going. So we're getting a lot of wonderful solar activity. We're getting sunspots, we're getting flares, and of course, that means lots of chances for aurora. And what's all over the news now is that, of course, there was a big geomagnetic storm on the sun. So if you've been watching a space weather, which I always recommend, um, there's been a great big geomagnetic storm and a lovely, lovely set of northern lights in Canada. The colorful sort of curtains in the sky should, in theory, be visible again tonight, Monday night. So if you're listening to this live, go out and have a look uppity. The northern lights, and just as a reminder, these northern lights and light shows, they only can occur because that sun, that active sun putting out solar flares, puts out high energy particles. And those are carried along by fast moving solar wind. And if it's a particularly massive amount of material, sometimes we call that a coronal mass ejection or CME. This would be a huge expulsion of particles that travel much faster than a normal solar wind. And so if we do get even a glancing blow, our own Earth reacts to that. And so our interaction with our magnetic field on the Earth means we get a bit of a light show. And also, hooray, we have a magnetic field to protect us. So it would be very bad if you aren't protected by a magnetic field. So, of course, the astronauts and the satellites have to watch out for that. And we'll probably, there's been a few estimates of people taking bets as to how many Starlink satellites will get blasted out of orbit by this one. Um, and they had, I think, what was it, 150, 200 came down in one of them last year. Um, yeah, it's kind of crazy, but we do get the show, and we do have, of course, lots of things that can happen if it's a strong enough storm. So we like to measure how strong they are. The strength of the geomagnetic storms are measured by what's called the KP index usually. There's a couple ways to measure them, and they go from 1 to 9. The higher the number, the stronger the storm. So on Sunday, which was yesterday, the KP index went as high as 8, but by today it's down lower. I did actually have a look at the Aurora dashboard or the Aurora forecast. If you're interested, that's noaa.gov. They do a lovely Aurora forecast with a dashboard, and it will actually show you if it's green, which is basically a 10% probability of aurora, or um, uh, red, which is a 90% probability of aurora in your area. So if you check out the forecast for tonight around Ontario, it's roughly green.
Yeah.
But as you go north and especially northwest, throughout the night tonight, you do get a 90% chance of aurora in Canada. So even if you're not particularly far north, if you are in Canada and you look up towards the north, depending on the time, either the northwest or the northeast, you actually have a fair chance of seeing a bit of a show tonight if you're in dark skies. Because of course the other part of the puzzle is that aurora are really badly washed out by light pollution. So if you're in a city, you probably are not going to see too much unless it gets really, really, really bright. And of course, exactly what kind of show you get depends on how fast the solar wind is moving and whether those particles interact with the molecules in our atmosphere that produce the colors of the light. And the further south that we get the sort of region, then the farther south you can see the aurora. And of course, if you are in Canada, you have a bit of a better chance. Southwestern Ontario should look towards the northern horizon, and so get into a dark sky a dark sky site, I suppose. But with the forest fires as well, you do have to watch out because smoke and haze will also wash out things like aurora. So it's a fun it's a fun time to be a solar astronomer for sure. Did you want to add a little bit about that since you had a sky tonight, or shall I tell about hot exoplanets in the last
Oh,
5 minutes?
yeah, just go with the hot exoplanets.
So I will just give a little shout out to your Sky in the Night. So if you are watching on the OPV as well, on the YouTube broadcast, I believe we did get to see the planet Mars very briefly. Things like planets are great even in even in relatively bright skies. So the last little news item I had, which is just I thought would be fun for the last 5 minutes or so, is also from James Webb Space Telescope because
You
you
can't
know
avoid it.
it's like you can't throw a stick without hitting a James Webb Space Telescope story right now. It's amazing and we love it. So there has been a lot of exoplanet studies on the James Webb Space Telescope. We're finding more exoplanets, more varied exoplanets. They're being able to do studies of the atmosphere of these exoplanets, which is really, really great. So this one is WASP 121b. And what they did was this is an ultra hot exoplanet. And basically they said that they looks like they found what's called atmospheric methane. and silicon monoxide, which seems to indicate that the planet itself would have been formed in an area like that to our own solar system's gas and ice giants. So they think that the planet was formed somewheres farther away from its star, kind of like Jupiter and Neptune and Saturn are in our solar system. But it's ultra hot now, so this, this means that it must have heated up, and of course, getting the detection of real chemicals in another planet is really, really cool because, of course, these planets are so far away around stars that are, they're unimaginably difficult to image. Let's just put it that way. So getting direct images of these things is almost impossible, but people do occasionally manage to get direct imaging. Um, Now, because they have so many interesting features, when you actually are able to look at the atmosphere, and in this case, they were sort of doing an inventory of carbon, oxygen, and silicon, um, the fact that they also had methane suggests, and this is a suggestion by the authors of the paper, I might add, that maybe there might be strong vertical winds in this exoplanet, and that's based on modeling. But a lot of times when you're modeling atmospheres of exoplanets, they don't put in extremely strong winds. So WASP 121b is this ultra hot giant planet that orbits its star at about twice the star's diameter, which is really, really close. And it completes its orbit in about 30.5 hours. So we take one Earth year to go around our sun. This planet is going around in slightly over an Earth day, right?
It's zipping
30.5
around at
hours.
great speed.
It's it is absolutely cooking in more ways than one. It's going extremely fast, and the temperatures go above 3,000 degrees Celsius. They think that it has tidal locking, so one side's always facing the star and the other side's always facing the night. On the night side, it would be only 1,500 degrees, they think. But the date side temperatures would be so high that your refractory materials, so solid things usually resistant to heat, exist like gases. And so you could get this very, very strange superheated one side that could be whipping material around to the other side, creating this very strange, super hot planet. And they concluded that the planet WASP 121b might be accumulating its gas in the cold region and then, somehow getting, different forms of methane as evaporate and gas and liquid. And so you would have some sort of a disk of gas and dust surrounding the star based off of this planet's extremely perilous, shall I say, position. So they think now that this planet is, it's obviously going to suffer extensively for its extremely extremely hot and cold position because that's not very stable, right?
Yeah.
Um, but the fact that
Eventually
you
you're
have this here,
evaporating it away over time.
yeah, exactly, and it's how it's going to evaporate and whether it gets pulled into its star, um, and eventually gets eaten by the star. That's one possible thing that could happen to it. So it's one of these really interesting scenarios that we love to see, and the fact that they've actually measured the elements and detected the methane gives it some extra oomph because you can then imagine the super winds and the extremely stressed day side, and maybe do some astronomy art on the side. So it's a wonderful discovery, and I think I'll just recommend everyone to go read about WASP 121b.
So I see we are at time. We're just a minute after 10 o'clock now. So you have been listening to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself, Mary Helen Armour. This podcast and past episodes are available wherever podcasts are distributed. You can also always connect with us on Instagram with the handle at YorkU Observatory, or on Facebook at Allan I Carswell or Cosweb Ob. Our website is yorku.ca/science/observatory. And there we have a lot of interesting content and, links to past podcasts, all kinds, lists of upcoming events. Again, I'll plug, we have our Astro Fair running at the end of this month. And if you feel so inclined, you can make a donation to our student-operated not-for-profit observatory. Thanks for tuning in this evening. We wish you clear skies, maybe an aurora, and have a good night.
Have
Thank
a
you
good
for
night, everyone.
listening.